Claisen condensation is a very important carbon-carbon bond-forming reaction that involves the self-condensation of an ester to give beta-keto esters or its cross-condensation with another carbonyl compound to give the corresponding product in the presence of a base. In this video, we'll talk about the different types of reactions based on this condensation reaction and its mechanism. So let's begin. So as I said earlier, that Claisen condensation is the self-condensation of an ester. You can see here the two molecules of this ester molecule condense together in the presence of a base to give this beta-keto ester. Now, why we call it a beta-keto ester is because you can see here we have a ketone functional group beta to this ester moiety. Let's see how the mechanism works for this reaction. So we have this ester molecule and we're going to treat it with a base. Now you already know that the property of a base is to abstract any acidic proton, and you see that this ester is enolizable, and that means that we have acidic protons or alpha protons present in this ester molecule. So one of these alpha hydrogens will be abstracted by the base, converting it into an enolate anion, and that is why we call it an enolizable ester molecule. This enolate, is quite unstable, so it will collapse back, and as a result, it will react with another ester molecule present in the reaction mixture. And it does so from its carbon, and it allows the removal of this alkoxide anion. And so you can see that this carbonyl is restored in this fashion. This alkoxide anion is removed, and this alpha carbon, from which earlier we had abstracted a hydrogen with the help of a base, is now attached here. The carbonyl from the enolate is restored again, and it is attached with this alkoxy group. So the ester is restored in this molecule or enolate, and the second ester that reacted with the enolate is converted into a into a ketone by the removal of this alkoxide or ethoxide anion in this case. So we have the formation of a beta-keto ester. Now in this case, because we have only this ketone here, this ester here, and it's enolizable, so it is a self-condensation type of reaction, but we can also allow this ester to react with another carbonyl molecule, like for example any ketone for that matter. So if we have an ester that is for example non-enolizable, and allow it to react with another carbonyl molecule that is enolizable, and then let's see what we will have. So if we have this ester, and here we have a quaternary center, or you can say we may attach it to a phenyl group. So this is a non-enolizable ester molecule, and let's say we react it with an enolizable ketone, for example acetophenone in this case, and react them with a base. So you can expect what product would be formed. This ketone here, this acetophenone, is enolizable. So actually the base will abstract a hydrogen from this acetophenone. Let's see how it works. And so an enolate is formed here. And this enolate then in turn reacts with this non-enolizable ester here, again from the carbon. And so we have this phenyl group which has this ketone restored, and then we have attachment of this carbon here, and the phenyl group. And so you know that this is a 1,3 diketone formed in this case. So if a ketone condenses with an ester in the presence of a base, we get a 1,3 diketone. But if two esters condense together, then we get a beta keto ester. If, for example, we have two ester functional groups in the same molecule and we allow it to react with a base, the same reaction will happen, but this time intramolecularly. This reaction, or these two reactions that we discussed, these are intermolecular condensation reactions. But condensation may occur within a molecule if we have two ester groups at two ends of a chain, for example. So in that case, intramolecular condensation reaction takes place, which is known as the Diekmann condensation reaction, which we will discuss later on in another video. But for the moment, this is how Claisen condensation reaction takes place. We discussed its mechanism and its modification. Thank you so much for now. Stay tuned for more videos. See you later.